A photovoltaic system is made up of panels which produce DC power when exposed to sunlight, and an inverter which converts the DC power into AC power that is fed into the utility grid. In commercial rooftop and ground mount PV systems, there are three different inverter topologies: a central inverter, a traditional string inverter, and the SolarEdge solution. Let's first take a look at central inverters. Central inverters have expensive maintenance contracts and can only be serviced by specialized teams. This leads to high operating expenses. In addition, energy harvest is optimized at a full array scale, leading to mismatch-related power losses, and every inverter malfunction results in full array downtime. For these reasons, decentralized architecture that uses multiple string inverters instead of central inverters is gaining market share. String inverter topology allows higher system availability, lower land use, and lower operation and maintenance expenses. While central inverters are typically used in ground mount installations, string inverters are used in both ground mount and rooftop systems. Although traditional topology using string inverters is still used in the majority of large-scale installations, it suffers from a number of significant drawbacks. First, the system power output is limited. In traditional systems, panels are wired in a series as a string. Each panel has its own power production profile. This is a function of its manufacturing variables, installation parameters, and shading patterns. This means that panels don't usually work at their maximum power point. Second, the traditional system has design limitations. Strings are shorter, and all strings connected to the same inverter need to be at the same length, use the same type of panels, and be positioned at the same angle. Real-life installation constraints, especially in rooftop systems, result either in wasted roof space or unnecessary duplication of balance of system components. A third drawback is safety issues. The DC cables that connect the panels to a string carry high voltage as long as the sun is shining. The traditional inverter cannot shut down the DC voltage of the panels, and therefore there are serious associated risks for installers and firefighters. And lastly, a traditional system cannot track power output, temperature, or any other parameter of a single panel. This makes it impossible to identify specific panel-level problems remotely. When we started to develop the SolarEdge solution, we looked at the challenges posed by traditional systems and defined three goals: to optimize and monitor power generation of each panel, to use the same installation methods and components used to install traditional inverter systems, and to minimize long-term operation and maintenance costs. So, we developed a topology that meets all of these goals: the SolarEdge DC Optimized Inverter Topology. Our solution splits the traditional inverter functionality into two products: the Power Optimizer and a simplified inverter. The power optimizers are located on the panels, turning them into intelligent panels. These power optimizers maximize system output by providing panel-level tracking and real-time adjustments of current and voltage to the optimal working point of each panel. The simplified inverter is installed similarly to a traditional string inverter, but it is only responsible for DC to AC inversion and grid connection. In comparison to the limited design of string inverters, designers of SolarEdge commercial systems enjoy great flexibility and are able to fit more panels in a given space. Additionally, the SolarEdge solution enables connection of much longer strings. This significantly lowers the number of strings per system and reduces balance of system costs. Our solution includes two additional features: a panel-level cloud-based monitoring platform, which is accessible from any computer or handheld device, and an enhanced safety mechanism. The SolarEdge monitoring platform provides full data and reports at the panel, string, inverter, and system level. This allows for immediate fault detection, real-time alerts, comprehensive analysis, and remote troubleshooting. These important features reduce long-term operation and maintenance costs and increase system availability. To provide enhanced safety, we have incorporated panel-level safety mechanisms to protect installers, electricians, maintenance personnel, and firefighters. With the SolarEdge solution, whenever AC power is off, the high DC voltage of the string is reduced to a safe voltage. This solution meets new safety regulations in the major PV markets in which we operate around the world. To summarize, thanks to panel-level optimization of power harvesting, investors and system owners can expect higher revenues throughout the system's lifetime and future-proof against unexpected variables that could lead to underperformance. Long-term operation and maintenance can be managed from remote, minimizing the requirement for site visits and time spent on-site. Bottom line, with higher revenue and lower OPEX, the SolarEdge solution provides superior lifetime value for EPCs, O&M providers, and system owners.